Hello class, today we're going to be covering lesson 1.3, which is midpoint and distance. Now notice we're going to be having some formulas here, okay? So first of all, just in general, midpoint. Hopefully you remember a midpoint is a point that divides a segment in two, okay? We also saw, I was thinking this was congruent. Sorry, segment bisector. So we saw the word congruent in the last lesson, but now we're going to see the word bisect. Bisect really just means to split. So when you hear the word bisect, it's almost like, again, like if you were to take a segment and you were to physically cut it. Now you don't necessarily have to do a point. So you could use a line. You could use a ray. So it means split basically in two equal parts or congruent parts, but it doesn't necessarily have to be a point like a midpoint. So honestly, these two words are really the same. It's just one is a point and one has more variations, okay? So if we take a look at these examples down below, and again, I know I'm going to go kind of fast because I just don't want this to be a super long video. It says that VW bisects XY. So basically, if this segment bisects, it means this is a midpoint. So that just means that this side must be equal to this side. And so then it tells us that the length of XT is 40. So if this side is 40, then this side must be 40. Now just be careful because it says what is XY. So what is the whole thing? So then all you got to do is add them together and you say 80. So the word bisect, again, notice it's a segment really versus a point. So not much difference at all. Okay, number 2, notice it tells you to identify. So be careful of those words. I know many of us just try to go to what is the last answer, but they want you to identify the segment bisector. So you look at this and they're asking you, what is this object? And so I would say like point M. It's pretty basic. Notice down here, it says identify. Now look at this whole shape. So the entire shape, I would say is, so the bisector would be line M. So you just basically have to describe the shape, okay? Now they want you to give the length. So if you notice here, it says then find the length of AB. So if this is 13, this must be 13. So then the whole thing, if we put those together, AB would be 26, okay? So same thing down here. They want us to find the length of EM, which is on this side. So clearly, I need to figure out the value of X. So the only way to do that, notice how they're equal. These are called tick marks. So tick marks means they're equal because it's been bisected. Again, I will never ask you to write down the definition of these words, but do you see how they will come up in your problems? So the more you use them, by the time we get to like chapters 3 and 4, it'll be just like second nature to you. So these are congruent, and so I'm just going to make myself a little equation, and then I'm going to solve this. So I like my variables to be positive, so I would go to the right, and then I would move the 3, and that would be what? 18. And then I would divide off the 6. I'm kind of running out of room here. And I get 3. Now remember, that's not my answer. I have to plug it back in. So 15 plus 3 would give me 18 for EM. Okay? All right, let's move on. So if you notice on number 4, this is an exploration. What they're trying to get you to do is they're trying to get you to see what is the midpoint formula. So I'm going to do this real quick. J, K. So here's my segment. And they want us to find the coordinates of the midpoint. And so if we were in class, I would say, work with your person at your table, see what you come up with, blah, blah, blah. But again, I'm all by myself here. So what I would do is I would really kind of look at the slope. So I would look at this and I would say, okay, if I go down 1, 2, 3, 4, 5, 6. So if I go down 6, then I'm going to go over 2. So I know the slope is 3, but I essentially don't want that right now. What I want to think about is the midpoint is at the halfway. So I really want to go down half of this number. So I want to go down 3, and I want to go over half of this number, which is 1. So if I go down 1, 2, 3, and I go over 1, there is my midpoint. Now, that's great, but I'm really kind of lazy and I don't want to do that for every single question. Plus, what if this comes out to be, what if this was like 5 over 7? Well, that's not going to be really fun to count down 2.5. Like, that's going to be too difficult. So the formula that we basically use is you add your x's together. So notice 1 plus 3. And then, 1 plus 3, 1 plus 3. And then you take half of that, which is, so you take half of that, and so then that's 2. Look at where my x coordinate was. Okay? Then you're going to add the y's together, so 4 plus negative 2. And then you're going to take half, because we're averaging them. And notice, look at where my coordinate is, 2, 1. So the formula is basically you add the x's together and you divide by 2. And this is a comma, and then you're going to add the y's together and divide by 2. And so you're going to get an ordered pair. So you're going to get like an x comma y answer for your midpoint. So let's take a look at number 5. I'm going to add my x's together. So I'm going to go 1 plus 4. Now typically you probably do that in your head, but I'm just showing you the exact formula. So it's 1 plus 4, and then we're going to take negative 3 plus 2. So that's 5 divided by 2, and that's negative 1 divided by 2. Now, I don't care if you leave it like this, but a lot of people would probably go ahead and work this out. So that would be 2.5, and then this one people might just leave or something, or you can say negative 0.5 if you want. But notice how they came out to be decimals. Even if you gave me a piece of graph paper, I think the slope is going to be really difficult. So that's why the formula works awesome. Now, I am not going to ask you to recite this formula, but if you don't know this formula, it is going to be extremely difficult for you to do your problems. So why don't you try number 6 without me? All right, hopefully you paused it and tried it. If you haven't, quick hit pause. The correct answer is 4, 5. Okay, so if you got that, go down to number 7. So we're going to go 1 plus 7 divided by 2. And then we're going to take the y's. 2 plus 8 divided by 2. So this is basically the formula. And then notice if I take half of 8 and if I take half of 10. That's how I got my answer. Okay? All right. Now we're going to kind of make it a little harder. So again, sometimes when you feel like you're like, oh, I'm doing good, I got this, they add a twist to it. So let's go ahead and let's go ahead and graph this. Okay, so we got m is 2, 4. Now notice that's the midpoint. One endpoint is t, which is 1.2, or sorry, 1.1. So this is t. Now I'm going to grab a quick ruler here. The segment is TU. So if I go from T through M, they're basically asking me where is the other endpoint. Well, again, if I was with you, hopefully you would be saying, I would just count the slope. So I would go up 1, 2, 3 over 1. Up 1, 2, 3 over 1. Notice I can't even draw a straight line with a ruler. So my other endpoint here is U. So that means U is 3, 7. Now, once again, though, I really do not want to do this every time. So there's another way that you can do this. And basically what it is you're using the formula backwards. So let's just think about this is our endpoint. So if we take our x, we do 1 plus the other endpoint, because we don't know it, that's u. We're going to divide that by 2, and that's going to give us the midpoint x value. And so then we would solve this. We would times both sides by 2. we would get 1 plus x is equal to 4, and then we would subtract 1. So we get 3, which is what we have. And then we would do the same thing for our y-coordinate. We would take our y-coordinate, we would go 1 plus the missing y divided by 2 gives us the answer, which is the 4. And then we solve this, we multiply both sides by 2, and then we subtract the 1, and 8 minus 1 is 7. So you can make these equations if you want every time, but if you look at both of the equations, notice they both have the same procedure. You multiply by 2. See how they both multiply by 2? And then you subtract. Now, I do hate that this is a 1, 1. I kind of wish I would have changed this to be a different coordinate. But you subtract whatever this number is. So if this would have been a 6, notice this would have been a 6. And so then I would have subtracted the 6. So you don't necessarily subtract 1. You subtract whatever the coordinate is here. Okay? Let's try one so you can see. Because sometimes it's just better to see an example. Notice this is practically the same question. It says M is the midpoint of the segment. So if I don't have a graph here, 2, 7 is right here. 6, 1 is probably right here. And so basically you're asking me where is this other point? Well, the easiest thing to do is to work our formula backwards. So you're going to take the midpoint. Remember, this is the midpoint. You're going to take the midpoint and you're going to times it by 2. So if you take this and you times it by 2, that's 12, 2. Then we subtract, see how it says subtract? We're going to subtract the other endpoint. See, the formula is you divide and you add. So basically, we're doing the formula backwards. Instead of division, we're going to multiply. Instead of addition, we're going to subtract. So I've multiplied by 2, and now I'm going to subtract the other endpoint. And so 12 minus 2, I'm just writing over here so I have a little more space, and then 2 minus 7, and there's my endpoint. And if you want to check it, add your x's together. So add 2 plus 10, so that's 12, take half. Add your y's together. 7 plus negative 5 is 2, take half. So I can tell you I've done it right. Why don't you pause the video here and try number 9. Just notice that S is the midpoint. So here is the midpoint. So if you want to change this to be an M, you could. It's not really going to make a difference. So go ahead and pause it here. All right. So the correct answer for T is 4, 3. So if you got that right, go ahead and go down to distance. If you didn't get that right, let me quick show you. You're going to times this by 2. So that's negative 2, 2. And we're going to subtract. Now you have to be very careful here because you've got some double negatives. So you're going to go negative 2 minus a negative 6. Remember, that's going to zip zap. So negative 2 plus 6 is 4. And then same thing here. You're going to go 2 minus a negative 1. Notice how those zip zap and it becomes a 3. So I'm still using the formula, it's just you got that double negative, so you got to be careful. All right, now distance formula. We didn't have you do any explorations for this one. We could, it's in the student journal, but it's really long. So I'm just going to flat out tell you what the distance formula is, and it's got the big square root in it. So you're going to subtract your x's, quantity squared, plus the difference of the y's, quantity squared. And again, I am never going to ask you for this. Sorry, this just got to be a little mark. I think the highlighter fell out of my hand, so that's nothing. I am never going to ask you to write this down. Your problems look exactly like numbers 10 and 11. So if you don't know this, it's going to be extremely difficult, because what typically happens is if you look at this, where these fall, 1, -3, 4, 2, they're not vertical or horizontal. If these were vertical, if you had R and you had S, you could just physically count like 1, 2, 3. But yours will be on a diagonal, so you're going to need to know the formula. So this is my x1, y1, x2, y2. So what I'm going to do is plug these into the formula. So I'm going to start with my second x. So I'm going to go 4 minus my first squared. So I'm doing the x's first. Those are my x's. Then I'm going to do my y's. So I'm going to do 2 and then -3. 2 minus a -3. So see how I zip-zapped it there. Now, if you have a graphing calculator, depending on the model of your graphing calculator, you're going to need to be really careful, because if I show you these two different calculators, the square root behaves a little differently. Just trying to position it so there's not a huge glare. So do you see how this square root, the bar will continue? So I can actually type this entire problem in without any issues, because do you see how my bar continues? On the older style calculator, if you do this, it's going to only take the square root of the first parenthesis. So this calculator is going to give you the wrong answer. Sorry, you can't really see the answer there. There we go. It's got a little glare to it. So if your calculator does this square root with a parenthesis and the bar does not continue to go straight across, what I would tell you to do is do it in 2 stages. So do the piece underneath. Now, I realize you might be able to do this in your head, because obviously that's 3 squared and that's 5 squared, but I'm just typing it in so you can see it. So if you do the underneath, you get 34. Then just go second square root of 34 and you'll get the same answer then. Okay, so you just got to be kind of careful on the calculator that you have. My square root continues, so I can type it all in at one time. So then this would be about 5.83. I would say rounding to 2 decimal places is plenty. We don't need to worry about the rest of that stuff, okay? So why don't you pause it here and try number 11. We're almost done. All right, if you tried number 11, I came out with the square root of 72, which is about 8.49, again, if you round a little. So if you got that correct, go ahead and fast forward or go ahead and start to read number 12. But I'm going to go ahead and go through it with you. So it is the difference of the the x's first, 7 minus 1 squared, and then the difference of the y's. So we're going to go 8 minus 2, and then squared. So if we work this out, that's 6 squared. 8 minus 2 is also 6 squared. And so if we add that together, we get 72. And then I just took the square root of it, okay? All right, we just got a couple little applications here. Again, if you want to pause it and you want to read number 12 on your own first, that would be great. Okay. So if you've read this, sometimes it can be a little confusing the way it's laid out. They're really basing everything here from your apartment. So what I kind of thought of is like almost like my apartment was like 0, 0. Like I based it off from the center of the graph, so to speak. Okay. So it says your school is 4 miles east and 1 mile south. So here's my school. So I said 4 -1 because it's all in miles. So it's the same unit. The recycling center is 2 miles east and 3 miles north. So let's say this is the recycling center. So 2 east and 3 north. It says find the distance between the recycling center and your school. So you really just need these 2 coordinates. You don't really even need the apartment. So now I would do the difference of my x's. And it really doesn't matter which one is first and second. You just need to make sure if you call this the first, you need to make sure you keep your pattern. So I'm going to probably call this x1, y1 just because it's on the top. So I go 4 minus 2, and then I'm going to go negative 1 minus 3. And then let me grab my calculator because I didn't already work this one out. Here, I'll do the underneath first. So that's 2 squared. That's negative 4 squared. Now be careful if you have a graphing calculator. You got to put those in parentheses or it's going to give you the wrong answer. So this happens to be the square root of 20. And then you get about 4.47 miles. Okay? All right, number 13, not quite as much to read. It says the dimensions of the court. The center of the court is located at the origin. So again, this is your 0, 0. It says, find the ordered pair that represents the location of a player in the bottom right corner. So if this is the center and this whole thing is 94, then wouldn't the right side be half of 94? So then this must be 47. And if we're going on a grid, then this would be like negative 47. Now remember, distance is always positive, but if we lay this out on a graph, like if this was my graph, I'm just trying to get the coordinates. So I'm going over 47, so over 47, and then down. So notice this is 50, which means it must be 25 above and 25 below, but because it's below, I'm going to do a negative. So I'm going to say negative 25. So that would be what I would put here. For the bottom right corner, I would say 47 and negative 25. Now it says find the distance that the ball travels. Well, again, if you're starting at the center court and you're going to here, you just need to do the distance formula using those two. To me, it would be easier probably to call like this one, like my second. So I can do 47 minus 0. It doesn't matter. So you can either do 47 minus 0, or you can go 0 minus 47. Because when you square it, it's going to turn positive anyway. So it's not going to make one bit of difference. So I'm going to go 47 minus 0. And then I'm going to go negative 25 minus 0. And I have no idea what 47 squared in my head is. So let's go 47 squared plus 25. I like you to get in the habit of putting the parentheses around them, because if you forget it on a negative, it's a problem. If you forget it on a positive, it's not. But if you forget it on a negative, it is. Okay, so this is going to be a big number. So we got the square root of 2,834. So let's just take the square root of that. And we get about 53.24. I think this was in feet, okay? So hopefully that makes sense. Please, please make sure you study your midpoint and your distance formulas because you're going to need those. So make sure you study them.